Okay, fine. So you've been given a second order initial value problem, and then you need to convert it into an integral equation, specifically a Volterra integral equation. As you can see, we have y of x here, and we have y of x, y prime of x out as well. So when we'll be integrating, we will have a function of x in as well. Now, in order for us, Roger's coach, I'm already recording. In order for us to be able to convert it, we are going to integrate. To make our work easier, I've decided to let the whole of this part, because this is a function of x, and this is also a function of x. So I've decided to just break it down and call it f of x. So I will have my y double prime of x is equal to f of x. I hope you guys are writing. Now, first, I am going to integrate with respect to t between the limits 0 to x. So let me write integrating with respect to t between the limits 0 to x. What are we going to have if we are integrating this with respect to t between the limits 0 to x? What is it going to break down to? Now, if we are integrating y double prime of x, we will have it as y prime of x. We are integrating this. It was double prime, now it will be prime. So we will have y prime of x is equal to integral from 0 to x of f of t dt plus some constant of integration. So let our constant of integration be, let's say a. This is the first time we're integrating. This is what we've integrated. It was y double prime, now it's y prime of x. We've integrated f of x from 0 to t with respect to dt. So we have integral from 0 to x of f of t dt plus some constant of integration. Okay. Again, integrating. So we are going to integrate again. Allow me to open another page. I hope you guys have written up to that point. So integrating again. What are we going to have? So now, right now, we are integrating. Let me just write what we are integrating again, because we'd written it the other side. We had y prime is equal to integral from 0 to x of f of t dt plus a. So integrating again, we are going to have it as integral from 0 to x, another integral from 0 to x of what do we have here? F of t dt plus integrating this is integral from 0 to x of a dt plus another constant of integration, which is b. So this translates to integral from 0 to x, integral from 0 to x of ft dt. Remember, using Cauchy's formula, we can be able to evaluate this double integral. But first of all, let's have this. So a is a constant of integration. You can take the a outside. Taking the a outside, if you integrate 1 with respect to t, so I am going to evaluate it here. Integrating, taking a outside, we remain with 1. The integral of 1 with respect to t is t. And then you have t, limits of integration are from 0 to x, and then we have plus b, constant of integration. So this translates to 0 to x, integral from 0 to x of ft dt plus a. Replacing the limits, what do we have? So replacing the limits, where there's t, we put x. So we are going to have x minus 0 plus b. So this simply translates to, we integrated, on this side, we integrated y prime. So what we are going to have is y of x. So y of x is equal to, now, let me write it here. Integral from 0 to x, integral from 0 to x of ft dt plus a of x plus b. Yes, Samsung SM, you have a question? Let me allow you to unmute yourself so that you can be able to ask. Yeah, you can ask the question. Samsung SM, you've raised your hand. Do you have a question? Or you've done it without knowing? Can you talk? Unmute yourself and talk. Unmute yourself.
Sorry, I don't have a question. I'm sorry.
Okay, then you can lower your hand. Okay, let's continue. So I hope you guys have written up to that point so that I'm able to open another page right up until that point.
You've not written.
Okay, write very fast. Samsung, your hand is still raised. Okay, can I open another page? We've done it up until this point.
Yes, you can proceed to another page.
Okay.
Wait.
So we had written it up until the point whereby we had our y of x is equal to the integral from 0 to x, integral from 0 to x of ft dt plus ax plus b. Now recall Cauchy's formula. So using Cauchy's formula, I'm not going to write the Cauchy's formula, you have it in your books. So recall Cauchy's formula. Using Cauchy's formula, we can be able to evaluate this double integral. Remember, when I gave you Cauchy's formula, we would use it to integrate integrals to any power. So this is a double integral. So we can be able to have our y of x being equal to the integral, if we transform it into a single integral from 0 to x of x minus t f t dt plus ax plus b. This we've done using Cauchy's formula from this part to this part. Now, we were given some conditions. Recall the initial conditions. Initially, we were told, so using the initial conditions, remember, if you look at this clearly, you can see it's already some sort of an integral equation. We have the integral sign there, we have the y of x there, we have this. So using the initial conditions, let's break it down. Now we were told that y of 0 is equal to 1 and y prime of 0 is equal to 0. Now, if y of 0 is equal to 1, we can be able to substitute in this final equation here, y of x. So y of 0 is equal to 1. So meaning y of, when x is 0. So y of x, let me write it up here, is equal to integral from 0 to x of x minus t, ft dt plus ax plus b. Now, since y of 0 is equal to 1, y of 0 is equal to 1, where there's y of x, so we'll call it y of 0, it will be 1, is equal to where there's x, we will put the 0. Now, I don't have to replace this. Okay, I don't have to replace this simply because if I replace, when x is 0, it's like we will be integrating from 0 to 0 of 0 minus tft dt. It doesn't really matter. Whatever it is that we get here, if we are integrating from 0 to 0, then basically what it means is that we are going to get a 0. Whatever it is that we're integrating here, because it's from 0 to 0. Let's say we get t squared, it will be t, let's say we get t squared as the answer. Then from 0 to 0, it will be 0 minus 0. So the whole of this gives us a 0. Plus, x is 0. So here we have a of 0 plus b. So this basically means a of 0 will give us a 0. B is equal to 1. So we have the value for b there. Now, using the second initial condition, we evaluate again so that we can be able to get the value for the other constant. So the next condition says that y prime of 0 is equal to 0. What was our y prime in evaluation? Recall, we got our y prime to be equal to, y prime of x was equal to integral from 0 to x of f of t dt plus a. Now, if this is what we got, so what is our y prime of 0? Y prime of 0 is 0. So this will be 0 is equal to, where there's x, put 0. Integral from 0 to 0, that will give us 0 on that side, plus a. So what does this mean? Our a, this basically means a is equal to 0. So we have the value for a and we have the value for b. We can be able to replace here. A is 0, so this part is going to disappear, and then b is 1. I want to write the final answer. Have you guys written up until this point? So we got that our y of x was equal to, I want to write it again, y of x was equal to integral from 0 to x of x minus t dt plus ax plus b. And we've gotten our value of a to be equal to 0 and b to be equal to 1. So our y of x is equal to integral from 0 to x of x minus t dt plus the whole of this will give us a 0 plus 1. I can be able to arrange this as y of x is equal to 1 plus integral from 0 to x of x minus t dt. Now, I want one of you to tell, now recall, when we initially started, we said, let our f of x be equal to lambda of x plus g of x. So where there's our, sorry, there's f of, I've not written f of t here. There's f of t here, f of t here, and f of t here. So y of x is equal to 1 plus integral from 0 to x of x minus t, f of t. Where there's f of t, we can be able to replace with this value that was there initially. So we can have it as lambda of t plus g over t dt. Yeah. And this is our Volterra integral equation. As you can see, the limit is from 0 to x. And it's a Volterra equation of first kind or second kind. Volterra integral equation of second kind. If you have a question, ask. If you have a question, ask or raise your hand.